Obviously, I collect color wheels, but also I'm an artist and designer, so sometimes people ask me, which color wheel do I actually use, like as a tool in the studio? But before I can answer that, first we have to establish, what are color wheels even for? As tools, they tend to try to solve some combination of the following three problems: how to predict the results of colorant mixtures, how to assess and choose harmonious combinations of color, and how to visualize colors, positions, and relationships within a color space. Most color wheels fail at these tasks, especially when they try to do all three. So as a case study, let's take the Color Wheel Company wheel. On one side is our paint mixture prediction computer. It only gives us one stop along each path between two colors. For instance, it tells us that mixing blue and orange will give us this olive sort of color, but it doesn't tell us about all the other possible desaturated oranges, yellows, greens, teals, and blues that we can get by mixing a blue and an orange pigment. And Lord knows how we're supposed to get this lavender from mixing yellow and red violet. On the flip side, we can rotate the mask to designate which hue is home base, but at all times, regardless of rotation, only 10 colors out of 36 are masked. So to try and isolate your complements or your triads, you have to already know how to do 90% of the work of how to balance or contrast or use different tones or shades in a design. Finally, the hue intervals on this are not perceptually even. By using the red, yellow, blue theory to space out hues, rather than a perceptual model like the Munsell system, the wheel fails to correctly identify hues of maximum contrast or regular perceptual intervals. So yeah, this wheel fails on all three tasks. Some wheels do better by just trying to do one job well. For instance, this is Merv Moriarty's wheel from Australia. It does a better job of solving problem one, since it visualizes mixture paths and not just one random stop along those paths. And Hal Reed's color wheel does a better job of solving problem two because it's based on the Munsell system, a perceptual system, and it masks more of the hues that are not supposed to be part of a given harmony. I don't, though, tend to personally reach for a color wheel that solves either problem one or problem two because I know that colorant mixture is far too complex to predict with a disc, and I know that color combinations are very context dependent. So I usually only find useful charts that work to solve problem three, specifically pigment charts that can instruct me on the positions and relationships of different paints in a perceptual color space. So this week we're looking at Bruce Makavoy's Artist's Color Wheel. The final version of this was published on his website, handprint.com, in 2009. It's a chart of about 80 watercolor pigments that I've been studying for years. In fact, I'm kind of nostalgic for this thing. In many ways, Makavoy's chart inspired my own work in color theory. Makavoy's massive project of measuring, analyzing, and charting watercolor pigments is just... I'm awestruck by it. He analyzed hundreds and hundreds of paints of every brand, creating an encyclopedic resource, including many charts, including this one. In part, Makavoy was motivated to do this because similar charts that have been around for decades were not rigorous enough. Take the Quiller wheel, for example. Manganese blue might be the most vivid cyan pigment in watercolor, but no way is it the same chroma as cadmium scarlet. In no way is Viridian on the same chroma level as cadmium yellow. He's using a sort of relative chroma, not an absolute chroma, to compare colors. And the lower chroma colors are plotted sort of by eye, like Venetian red. No way is Venetian red more chromatic than burnt sienna. Makavoy did proceed scientifically. He used a spectrophotometer. He's arranged on this chart about 80 pigments by the best perception science-based color appearance model he had access to at the time, CCAM02. I like that model, and I think it's a good choice for charting paint pigments, and here's why. It's a model that accounts for context and chromatic adaptation, meaning the way our vision adapts and adjusts to things like bias in the lighting or colors juxtaposed next to each other in our field of view. You can input different illumination and context parameters when modeling color situations with CCAM02. How does all that affect the geometry of an artist's color wheel, though? In my experience, it means that the center of the space is sort of blown out. In other words, the distances between low chroma colors on the chart are more emphasized than the distances between high chroma colors compared to other color spaces. And for me, that captures something very accurate about the way I judge paint colors against each other in the studio. The difference between, say, raw umber and burnt umber may not be very big in terms of absolute hue or chroma, but when you judge those browns against each other on your palette, those small differences become more important. Finally, a caveat. This wheel is watercolors only, not acrylics, not oils, not pastels. And the medium can affect the chroma and hue of a given pigment. So if you're looking for a more comprehensive web-based project that charts a more inclusive database of media, check out artistpigments.org. That being said, I have to hand it to Makavoy for buckling down on problem 3 and delivering a useful tool. Thanks for watching, and let me know if there are other color wheels you would like me to dissect on the next Color Wheel Wednesday.